Hello, this is Ms. DB, and today we're going to talk about solving equations and inequalities. This is from Chapter 2, Section 1 of your Algebra 2 book. This should be a review of your Algebra 1 course. You probably did a lot of solving equations and solving inequalities when you were in Algebra 1. An equation has an equal sign. It's a mathematical statement that two expressions are equivalent or equal. The solution set of an equation is the answer. It's the value or values of the variable that make it true. Usually that's just one, but we're going to look at some examples today where more than one value would make that true. A linear equation in one variable can be written in the form ax equals b, where a and b are constants and a is not equal to 0. Here's some examples of linear equations in one variable. 4x equals 8, kind of real basic. The next one, 3x minus 2/3 x equals negative 9. And the last one, 2x minus 5 equals 0.1x plus 2. So some of them, like the first one, 4x equals 8, can be solved in one step. Some of them will take 2, some of them will take many steps to solve. There's some examples on the other side of nonlinear equations. Those are not ones that we will be solving at this time. So the variables that we're going to be working with is just, there's no power, there's no square root, it's not an exponent, the variable is not in the denominator, so we're just going to be doing the basic ones. Our goal is to get the variable by itself. That's how you solve linear equations. These are the properties that we'll be using. The addition property says that you can add the same number to both sides of an equation and it doesn't change it. The subtraction is you can subtract the same thing from both sides and that's just fine. Multiplication, you can multiply both sides of an equation by the same number and the equation is still true. And division, you can also divide both sides of an equation by the same quantity and the equation will still be true. So we are going to be using inverse operations on both sides of the equation. Try to show your steps, try to keep the equal sign lined up, and do the inverse operations in the reverse order of the order of operations. All right, here's some, there is some examples on your worksheet of 1- and 2-step equations, but we're going to go ahead and just start out with more complicated ones. So in this one, we'll have to use the distributive property first. So one method is to say, well, let's see, we had m plus 12 and then it was being multiplied by 4. So to undo multiply by 4, I could divide both sides by 4. And that would look like this. And then you would continue to work, and if you divide both sides by 4, the 4's would cancel here. And you'd be left with m plus 12 is equal to negative 9. And then we have to undo the plus 12, so we would subtract 12 from both sides and end up with our solution of m equals negative 21. Now, you should know how to check these. You take the answer, in this case, negative 21, and you put it back into the original equation, and you do the math, and you see if both sides equal the same thing. If they do, then you got the right answer. If they don't, then you made a mistake and you need to go back and fix it. So negative 21 plus 12 is negative 9. Come on. And negative 9 times 4 is indeed negative 36. So negative 36 equals negative 36, and it checks. You do not have to show me your check on your worksheet. You should be doing it even if it's just on scratch paper or in your head. Oh, here's the check. All right, now, that was one method of solving this, but like many equations, there's more than one way to do it. The second method is do the distributive property first on the left side there. So that would be 4 times m is 4m, 4 times 12 is 48, and that's equal to negative 36. Then we just have a two-step equation, subtract 48 from both sides, and then divide by 4. Now you'll get the same exact answer. The check would be the same. So when you check it, you're going to get the same answer. Okay, so you can use either method of doing these problems. If you see that you know, if you know right away that 42 divided by 3 is something, 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 then that might be the best method. So if you recognize that 42 divided by 3 would be 14 and you'd get a smaller problem to work with, you could do that. Otherwise, you can do the distributive property first. So don't do both. Don't divide by 3 and distribute the 3. So in this method, we get that p is equal to -4, and then we would check that. And in this method, this is the method where you do the distributive property first. You would get 6 minus 9p equals 42. Subtract the 6 from both sides. Divide by -9, and we get -4. You'll get the same thing with either method. Let's check this one. So we would have 3 times 2 minus 3 times -4. I don't know what's equal yet. And then I would do this part and get 12. So inside the parentheses I'd have 2 plus 12. And 2 plus 12 is 14. And apparently 3 times 14 equals 42 because we just saw that on the last screen, so it checks and we got the right answer. Another example, same type of problem. This first method is to divide both sides by the number being multiplied. Now this only works if the -3 is multiplied by everything else on the left side. If we had like a +3 here, then this method wouldn't work. If we had something after the parentheses. This only works if you have a number and parentheses, and then all of the rest of the stuff is in the parentheses on the left side before the equal sign. But if you have that set up like that, then this is a valid method of solving your equation. So we would end up with, be careful here, 1/2. A lot of people, for some reason, when they see the 2 and the 4, they're like, oh, the answer is 2. In this case, the answer is 1/2. You can get fractions or decimals for solutions. Now, I would probably do the other method where you distribute first. So I would go ahead and simplify and get -15 plus 12r equals -9. And then I would add 15 to both sides to get rid of the -15 and get 12r equals 6, and then divide both sides by 12, which is 6/12, and I would have to simplify the 6/12. So in the other one, you got 1/2 as your answer without simplifying. In this one, I would have to recognize that 6/12 is the same as 1/2. These are the problems from your worksheet. Now, each of them are set up so that you can use either the method 1 or the method 2 that we just went over. You get to pick which one you want to do. Number 4 looks different, but it's just because the distributive property is on the right side instead of the left side. So we will still do the same thing. Let's say I was going to use method 2 here. I would still distribute the 3 through, and then your next step would be to add 9 to both sides. And make sure that you don't make a mistake on your negatives. This is -27 plus 9. So use your calculator to check if you have to, but this would be -18 equals 3x and divide by 3, and you get your answer of -6. And again, you should be checking your answers, because if you have it wrong, if it doesn't check, then you can fix it before you turn in your work. And you don't have to show me the check, or you can do it off on the side on a scratch piece of paper, but you don't have to turn that in. So -6 minus 3, that'd be -9. -9 times 3, yep, is -27. All right, now, a lot of times our equations are even more complicated, and we might have variables on both sides of the equation. So what we're going to do is this. We're going to simplify each side first, like we just did with the distributive property. That's simplifying, or you add like terms. Then you collect all the variable terms on one side, and you get the constants on the other side. By collect, you're going to have to use your properties, like the addition property or subtraction property, and do the same thing to both sides. And then we'll isolate the variables just like we just did. All right, let's look at an example. These are my favorite. All right, so we have on the left side 3k minus 14k plus 25, and on the right side 2 minus 6k minus 12. On the left side, we're going to simplify this. We're not going to combine it with the right side in any way. So let's see, we've got like terms here and here. 3k minus 14k. Well, 3 minus 14 is minus 11k. 25 doesn't have any like terms. And then on the right side, my like terms are my constants, which is 2 and minus 12. So that's negative 10. Okay. Next, I need to collect the variables on the same side. So that means that I need to either move the negative 11k or the negative 6k. I'm going to get rid of the minus 6k by doing the addition property, which says that I am allowed to add the same thing to both sides and it doesn't change my equality. So that means that it's gone over here because negative 6k plus 6k is gone. Negative 11k plus 6k is negative 5k. Watch the negatives. Then rewrite what you have left. All right, I need to get rid of the plus 25. It's a two-step equation now. It's getting simpler and simpler as we go. Just keep using your properties to isolate the variable and find your answer. All right, I'm going to erase my marks. I would check that too by just putting k back in and figuring out what I would get on each side. And if I get the same thing on both sides, then I know I did it right. Let's see if they have all the same steps. So they did a different step right here. Instead of adding 6k to both sides, they added 11k to both sides. The result of that was that you got positive 5k on the right side instead of the negative on the left. But everything else is going to be the same. 7 is the answer we both got. All right, let's look at another example. More fun with equations. On this one, when we simplify the left side, we're going to first have to do the distributive property. And then after that, we will do adding like terms. So they skipped the distributive property step. So I will add that in there. So we would do first 3w plus 21 minus 5w equals w plus 12. And that step is distributive property. All right, step 2 is to simplify by combining like terms. So there we have a 3 and a minus 5. Remember, the sign in front of the term goes with it. So negative 2w plus 21 equals w plus 12. Now we need to get the variables on the same side. It can be either the right or the left. It doesn't matter. They said let's add 2w to both sides. That's legitimate. Remember that this is like a 1w. So now we would have 21 equals 3w plus 12. Subtract 12 from both sides, and we get 3w equals 9. Divide by 3, and we get our answer of 3. These are your examples from your worksheet. You can see that they're not too bad. In number 5, you don't even have to combine like terms or do the distributive property. You can go ahead and start by getting your variables on the same side. I would subtract 2a from both sides, but you might prefer to subtract 5a from both sides, which would give me 3a plus 3 equals 9, and then so on. Finish that up. Dot, dot, dot. It is possible that you will get decimals or fractions for the answers. In number 5, you should get an integer though. Okay, number 6. Let's see, we've got 8y plus 1y equals 3y plus 30. So the first step would be to combine the 8y and the 1y. And then you would subtract 3y from both sides and continue. This is the same as 1x here. So again, your first step is just to combine your variables on the same side. So I could subtract 1x or I could add 3x to both sides, whichever method you prefer. And in number 8, finally, you get to do a little bit more work and do the distributive property first and then continue. So I think these 3 you would get integer answers. In this one, you'll get, I don't know, I can't do that one in my head. I think you will get an integer for all of these. I don't think you'll have any decimals or fractions. All right, now I told you at the beginning that there's some times where you'll get more than one answer will work when you solve an equation. Sometimes there's no answer that'll work. Sometimes you will get any answer would work in the equation. For example, 5x equals 2x plus 3x. If I go ahead and combine my like terms on the right side, I get 5x. 5x equals 5x. No matter what value I use for x, this will always be true. This is called an identity. When you get an identity, your answer that you write on your paper is all real numbers. Sometimes when you're solving, you'll get a contradiction, like 3 equals 5. You'll get a false statement. And what you write then on your paper is no solution. There's no value of x that would make it true. Here's an example. Let's see what we get. So the way you do these problems is you go ahead and you start solving just like you normally would. So 3v minus 4v is minus 1v minus 9. On this side I have to use the distributive property and I would get negative 5 minus v. And then my next step is to get my variables on the same side. So I'll add 1v to both sides. When I do that, when I add 1v to both sides, on the left side and the right side, I lose my variable. I have no variables left. If you have negative 1v plus 1v, it's 0. It's not v, it's just 0. So I'm left with negative 9 equals negative 5. That is false. That is not true. So my answer, when I get a contradiction like that, when I get a false statement, what I write down on the paper is no solution. They're just going to go through those same steps in a slightly different order. All right, let's try this one. So again, we start the same way. Let's see, I'll do the distributive property here. On the right side, I'm going to go ahead and combine my like terms. Now right here, some people would stop and say, wait, 2x minus 12 equals 2x minus 12. I have the exact same thing on both sides. If you recognize it right there, you can stop. These are the exact same thing on both sides, so this answer is going to be all real numbers. But a lot of people won't see it yet. They'll say, okay, now I got to subtract 2x from both sides. Now 2x minus 2x is 0. You don't write down 0. You don't write down anything. The variable is gone. On this side, 2x minus 2x is also 0. You don't have to write that down. You just write negative 12. Now negative 12 is equal to negative 12. Now I can say all real numbers, because this is an identity. Identity is when you get a true or something equal to something else that's true all the time. Okay, on this example, let's see, we do the distributive property first, combine our like terms, subtract the 5x from both sides, and we're going to get a false statement. This is never true, so our answer is no solution. Or you can put the empty set, which is null. It's the circle with a line through it. You might be able to find that in Word under symbols, or you can just write no solution. In this example, it's the same basic setup. And in this one, we have the exact same thing on both sides of the equal sign. This is called an identity, so the answer is all real numbers. Here's the examples on your worksheet. Don't assume that number 10 is all real numbers until you start simplifying it. But each one of these, you're going to, let's do number 11. You're going to simplify as far as you can, just like you're solving an equation. You are solving an equation. But if you have the same thing on both sides, as soon as you recognize that you have the exact same thing on both sides, then you can say, oh, this answer would be all real numbers. If you get different things on both sides, if you end up with something like 2 equals 3, then your answer is no solution. But you can still do your steps and solve the equation just like you normally would. It's just at the end, when you look at what you have for a result, that's when you would write either no solution or all real numbers. All right, last part we're going to talk about is inequalities. That's when you have a less than or a greater than. Remember that this is less than. If you put a line under it, it's less than or equal to. And that means the other way is greater than. And if you put a line under it, it's greater than or equal to. You can make these symbols on your keyboard. The less than is right next to the M key, and the greater than right after it, right to the right of that. If you underline the less than or the greater than, then you can add the this part of it that you need. The only thing you have to remember when you're solving an inequality is if you multiply or divide by a negative number, then you reverse the inequality symbol. So if it was less than and you multiply both sides by a negative, then you flip it to greater than. All right, so the properties also apply to inequalities. And they are that if you multiply by a negative, you reverse it and it'll still be true. Same thing for dividing. To check an inequality, test the value being compared with x, a value less than that, and a value greater than that. All right, so let's do this one. Now they're going to say graph. You don't have to make the graphs in your worksheet. You can just tell me what the graph would look like. Or if you're doing it by hand and scanning your work in, then you can go ahead and make the graphs if you'd rather. So in this problem, we are going to simplify this inequality just like it was an equation. We need to get the variables on the same side, so we subtract 13a from both sides and get negative 5a minus 2 is greater than or equal to 8. Then we'll add 2 to both sides and get negative 5a is greater than or equal to 10. I pushed the button twice there. Now here's where you have to be careful. Right here, I can see that I have to divide by a negative number. When you divide by a negative number, you change your less than or equal to a greater than or equal. Oh, they reversed it right here. Sorry. They already did it. They changed their greater than or equal to a less than or equal right here because they were dividing by a negative. So this becomes a is less than or equal to negative 2. And now we would graph that. So you draw your number line. Here's 0, negative 1, negative 2, negative 3. If it has a line under it, if it's less than or equal, I put a solid dot. I fill it in, and I want all the numbers to the left, smaller than it. If it is just less than, I would put an open circle here. For my answer, if I was doing this on paper, I would write solid dot at negative 2, arrow to the left. So they're checking this is their graph. And then to check it, they checked negative 4, which is right here. They checked negative 2 to make sure they were using the right kind of dot. And then they checked negative 1. You do not have to do this on your worksheet. All right, here's another example. First thing is to solve it just like it was an equation, but being careful that if we ever divide by a negative, we have to do some other extra steps. So subtract 1x from both sides, and you get 3x over here. So 8 is greater than or equal to 3x plus 17. Subtract 17, and 8 minus 17 is a negative 9, is greater than or equal to 3x. Then divide by 3, and we get negative 3 is greater than or equal to x. Some people prefer the x being on the left side. That means that this right now is pointing at the x. The small side is at the x. So when you rewrite it with the x on the left side, if you prefer it, then x is less than or equal to negative 3. Now to graph that, all you have to do, all you really need is to know that at the negative 3, there'll be a solid dot because it's less than or equal to, and all the numbers to the left. So for your examples on your worksheet, you're going to solve these just like they were equations and then describe what your graph would look like. Let's do number 14. I will start by subtracting 5w from both sides to collect the variables. And then I would subtract the 23, and I would get negative 21 is less than 3w. Oops, that's it. Just 3w. Divide by 3 on both sides. And I'll get negative 7 is less than w. Now here's a time where you might want to flip it around. That means that w is greater than negative 7. So again, if you're doing this by hand, you can graph that. Here's negative 7. Greater than, but not equal to, so I put an open circle, and then my arrow would go to the right. If you're writing this in Word, I would write open circle at negative 7, arrow to the right. So you're describing it. All right, I think that's it. Have a great day. Please let me know if you have any questions at all.